My name is Omar Ataway and I'm going to explain 6 past paper 1 IB chemistry exam questions for topic 2. So the first question says which statement of the electromagnetic spectrum is not correct. So you have to know that the higher the frequency is, the higher the energy is, and the shorter the wavelength is, and vice versa. So if you look at the electromagnetic spectrum provided to you on page 3 of your data booklet, you find that the gamma radiation has the highest energy, the highest frequency, and the shortest wavelength, and vice versa here. So the first statement says the wavelength of ultraviolet radiation is shorter than infrared radiation. So UV is here, and infrared radiation is here, and says that ultraviolet radiation has a shorter wavelength than infrared radiation, which is correct because UV has more energy than infrared radiation. Thus, it would have a shorter wavelength as per this. And then C says the energy of infrared radiation is lower than the energy of ultraviolet radiation. And this is correct because infrared radiation is located here, which is before ultraviolet radiation, and energy is increasing this way. So this would be a correct statement. And then D says wavelength is inversely proportional to frequency, which is correct because the higher the frequency is, the higher the energy is, which leaves us with B, and B is the incorrect answer because the frequency of visible radiation it says that the frequency of visible radiation is higher than the frequency of ultraviolet radiation, which is definitely incorrect because visible radiation is located here between ultraviolet radiation and infrared radiation. Therefore, visible radiation cannot have a higher frequency than ultraviolet radiation because ultraviolet radiation has more energy, and more energy equals more frequency. So visible radiation would have visible radiation would have lower energy because it's located before UV, thus it would have lower frequency. So your answer here is B. And then for the second question, it says what is the atomic number of a neural atom which has 51 neutrons and 40 electrons. Neural means that the atom has no charge, meaning that electrons are not lost or gained. So the electrons means that the electrons equal protons, and the atomic number equals the number of protons in the atom. So it says B, 51, and 51 is incorrect because it says asking for the atomic number, and atomic number does not equal the number of neutrons, and C would be incorrect because it's asking also for the atomic number, and atomic number does not equal the number of neutrons and electrons combined, and D is 131, which doesn't make sense. So all these would be incorrect because C is 91 and D is 131 and B is 51, and all these are incorrect. And it would be A because A is 40, and it says the electrons are 40, and it says the neural atom. So the electrons equal the proton, and the protons equal the atomic number, so it would be A, 40. And then the third question says, what is the electronic configuration for Cr with a positive charge of 2? So Cr is chromium, it has a positive, it has an atomic number of 24, meaning it has 24 protons, and here it says it has a positive charge of 2, which means it's a cation. When the cation is an atom that has lost electrons, and in this case it has lost 2 electrons, and to keep in mind, an anion is an atom that has gained electrons represented by a negative charge. However, in this case it's positive, so it's a cation, it has lost 2 electrons. So all the multiple choice answers here are written in the condensed form of AR at the beginning, argon, so you have to solve it using the condensed form. So in order to solve it, we're going to use the electronic configuration diagram. So we know that chromium has 24 electrons usually if it's a neural atom, and in this case it's positively charged by 2, so it's lost 2 electrons, so it has 22 electrons. So we're gonna solve first as if it's a neural atom, and then we're gonna subtract 2 at the end. So we're gonna do 1s2, 2s2, 2p6, 3s2, 3p6, and then when we reach this point, you have to know that chromium is an exception, meaning that you can't write 4s2 and then 3d4. This would be incorrect because it has to be 4s1, 3d5, and the reason for that is because it's better to have a half-filled sublevel because it makes it more stable. So this is the exception. And then we have to subtract 2 because it's positively charged by 2, meaning it lost 2 electrons. So in order to do that, you first subtract from the highest sublevel. The highest sublevel here is 4s1. So you subtract from it, and then we're left with 1 one extra electron, so we have to subtract again. So the last sublevel now is 3d5, and we subtract from it, and you're left with 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s0, 4s0, and 3d4. And then it wants it in condensed form, so you take this part is equal to 18, so you're gonna use argon. You can't use this because you can use argon, which is bigger. We're gonna make it more condensed, and you can't use this or this because they're too big. You don't have this, and so AR 4s0 3d4, which is your answer, which is written in D, multiple choice of D. D has written it as AR 3d4 4s0, which is also an accepted answer. Both ways are accepted. They're both accurate ways of writing it. So this is your answer for this question. And then the fourth question says, which statement about the species, let me write it, the species 63 Cu T plus and 65 Cu plus is correct. So the first one says that both species have the same number of protons, which is the correct one. I'm going to explain that why after I explain the others. So the B says both species have the same number of electrons, which is not true, because as you can notice, they both have a positive charge, meaning that they are cations. They'll have lost electrons. This has lost 2 electrons, and this has lost 1 electron. So they can't have the same number of electrons. So this is incorrect. And then D says they both have the same electron arrangement, which is also incorrect, since they do not have the same number of electrons. This has lost 1 more electron than this one. And then C says both species have the same number of neutrons, which is also incorrect, because they're both the same element with different atomic masses and different number of electrons, meaning that they're isotopes, and isotopes never ever have the same number of neutrons. So this would mean A is correct, because protons never ever change. They're always the same, no matter the charge, no matter anything. Protons never change. And then the fifth question says, in the emission spectrum of the hydrogen atom, which electronic transition would produce a line in the ultraviolet region of the electromagnetic spectrum? So in order to solve this, you have to know this. And this says that anything that drops down to a sublevel of n equal 1 produces an ultraviolet region. So produces an emission in the ultraviolet region. So if you drop down from, let's say, n equal 5 to n equal 1, that means you produced ultraviolet radiation. If you drop down from n equal 3 to n equal 1, that means you produced emission in the ultraviolet region. If you drop down from n equal 10 to n equal 1, same thing, and so on. So as long as it dropped down from a higher level to a lower level of n equal 1, from a higher sub-level of n equal 10, or energy level of n equal 10 to a lower energy level of n equal 1, then it produces UV. So if it dropped down to n equal 2, n equal 3, then they're wrong answers. It has to drop down to n equal 1 from a higher level. So this means that the correct answer is D. So the correct answer here would be D. It can't be C, because C dropped down from n equal 3 to n equal 2, so it's incorrect. And it can be B, because it dropped down from n equal 3 to n equal 1. I'm sorry, I meant the answer is B, because it dropped down to n equal 1. D is the incorrect answer, because it dropped down from n equal 10 to n equal 2, which is incorrect, because it also dropped down to n equal 2. And A is incorrect, because it dropped down from n equal 1 to n equal 3. It didn't even drop down. This is a lower energy level to a higher energy level. So this is incorrect. It didn't even release energy in this. Didn't release energy. It can't release energy because it didn't drop down. And it also isn't n equal 1. So it's incorrect. So your answer here would be B. And then the sixth question says, what does 24 12 mg2 plus represent? 24 12 mg2 plus represent? So this is atomic mass, which is protons plus neutrons, and this is an atomic number, which is the number of protons. and this is a simple number, which is magnesium. So your answer here would be let's see. So 24, let me write it down. So it says for A, an ion with 12 protons and 12 neutrons. So 12 protons is correct, because as we said, this is atomic number equals the protons, so it's correct. However, it says 24 neutrons, which is incorrect, because this is atomic mass, which is protons plus neutrons. So neutrons makes it up, but it doesn't equal the neutrons, so this is incorrect. And then B says 14 protons, which is incorrect, because the protons never change, and it says the protons are 12, and it also says 24 neutrons, which is incorrect, as we said. And then it can't be D, because D says it has 22 neutrons, which is incorrect, because you can't make up 22 neutrons, because you find the neutrons by subtracting the protons by the atomic mass, because atomic mass equals protons plus neutrons, so you subtract the protons from it in order to find the neutrons, which are 12. 24 minus 12 is 12, so it's C, because C says it's 12 protons and 12 neutrons, so it's C. So if you go here, answer is C. Now I hope you understood everything, and I hope you understood everything from my explanation, and thank you for watching.